All right, everybody, welcome to the video here for lesson number 16, the remainder theorem, the last lesson of our chapter. So the first question asks us to determine the value of P of 4 in two different ways. So the first way would be the easy way that you learned how to do it way back in like Algebra 1. So we're literally just going to plug in 4. So what the remainder theorem is telling us here is whatever this winds up being is the remainder if I was to divide by x minus 4 as a factor. So if I get P of 4, then type that in, so I have 4 to the third plus 6 times 4 squared minus 32 minus 1, so we get 127. Another way you could do this is you could graph it and figure out what the x value is, the y value is when the x value is 4. Or you could do some synthetic division and see what we get here for the remainder. All right, so we have 1, 6, negative 8, negative 1, bring down that 1. That's 10. That is 32. That's 128. Like that, another 127, so you know what the remainder is. So we know that the value of P of 4 is 127. For number 2, to determine if this is a factor of the polynomial, you can either divide and do your whole synthetic division thing with negative 1, or just plug in negative 1. So I could say 2 of negative 1 to the 5th minus 4 times negative 1 to the 4th plus 9 times negative 1 to the 3rd, etc. So this can become negative 2 minus 4 minus 9 plus 1 plus 13. So that's going to be whatever that comes out to be. Negative 1. So I can say x plus 1 is not a factor. Other ways I could determine this, I could do the long division. I could even graph this polynomial and see if it crosses the x-axis at a 0 of negative 1. Number 3, find the value of k so that this has a remainder of 16. So what's the value of k here if the remainder is 16? So to have a remainder of 16, when I plug negative 2 in, I should get 16. So I should be able to say 16 is equal to k times negative 2 cubed plus negative 2 minus k. So now if I do some quick algebra here, I have negative 8k minus 2 minus k. Or I have 18 equals negative 9k, or k equals negative 2. Number 4, let p of x equal this cubic polynomial, verify that p of 9 is 0. So to verify p of 9 is 0, I can either do long division, synthetic division, or just simply plug in 9. So if we just simply plug in 9, we have p of 9 is equal to 9 cubed minus 8 times 9 squared minus 29 times 9 plus 180. And plug that into my calculator, and I get 0. Then it says, express p as a product of 3 linear factors. So that means I want to factor out or divide out the factor of x minus 9. So if I do some long division here, so I put in my 9, I'll actually do it synthetically, it's quicker and easier. And we get our answer. So the 1 comes down. Notice the remainder of nothing. So that means p of x can be written as the product of the factors x minus 9, that's a linear factor, and the quadratic factor x squared plus x minus 20. But this is a product of 3 linear factors, so I got to get rid of that quadratic factor, and it's factorable, right? So I have x minus 4, x plus 5. There is your answer. Number 5, explain why this 51st degree polynomial is divisible by x minus 1. So if we put in 1 to the 51st minus 2, 1 times 1 plus 2, and do all of my multiplication and addition, we get 0. So that tells us that x minus 1 is a factor, meaning it's divisible by the polynomial. All right, so for number 6, if you're explaining why a polynomial function p has a value of p of a that is equal to the remainder of the quotient, you can always go through and look at it graphically. So when we're looking at a graph, if I have a value of a on the x-axis, wherever my graph is, this value is going to be p of a. That's essentially what they're asking you to explain there in number 6. Number 7 says, consider a graph of a 5th degree polynomial with x-intercepts, and it gives you all 5 different x-intercepts. Since there's 5 different x-intercepts, each one is going to have a multiplicity of 1. So it says, write a formula for a possible polynomial equation using k as a constant factor. So we could say p of x is equal to k times x plus 4, x plus 2, x minus 1, x minus 3, and x minus 5. It then says, suppose the y-intercept is negative 4. Find the value of k so that the graph passes through. So if the y-intercept is negative 4, that means it has a coordinate of 0, negative 4. So if I plug in negative 4 where p of x is and put in zeros for all of the x's, you wind up getting some things that multiply out that look like this. Now if you do some multiplication here, we wind up getting 8 and negative 15. So 8 times negative 15 is negative 120. So I have negative 4 is equal to negative 120k. Divide by negative 120. Double negative makes a positive. And now I know the k value is whatever that decimal is, 1 over 30. Number 8 says to consider this polynomial function, factor p completely. So to factor this, I'm going to take out a negative, and I'm going to rewrite that as x to the 4th plus x to the 3rd plus 6, so minus 6x squared, because I don't want the negative as the first term. Also, I noticed there is a GCF, so I'll take out an x squared, leave me with x squared plus x minus 6. And then I can factor that to x plus 3, x minus 2, because we're all super smart and we know how to factor that. So if each one of those factors gives us a 0, I can say the zeros of this function are going to be negative 3, 0 with a multiplicity of 2, and positive 2. So then I can put those on my graph. So I have a negative 3, a 0, and a positive 2. I also know since there's no constant value at the end of the function, it's not going to pass through the y-axis anywhere but at the origin. And we can sketch this graph without my calculator. I know it's a negative with an even degree, so I mean both the beginning and end are going to point down. I know it's going to pass through negative 3 because it's an odd multiplicity, and pass through 2 because it's an odd multiplicity. But it's going to be tangent at the x-axis at 0. Number 9 says find the quotient using 2 different methods. So if I put in 6, I have 1, negative 8 synthetically. The 1 comes down, I get 6, negative 2. So the answer is 1 plus negative 2 over x minus 6. And those of you that really enjoy doing that method of inspection, right, Quinn? You really like the method of inspection. You could do that here as well. So I could say x minus 8 plus 2 minus 2 all over x minus 6. Notice I'm adding nothing. So I have x minus 6 over x minus 6 minus 2 over x minus 6. So the 1 stays, and then we get the same answer either way. Honestly, I don't care which method you choose. It's totally your choice. Last question in the homework. Is this function odd, even, or neither? So to determine that, you plug in negative x, 4x. So I have this negative x to the 4th power and a negative x to the 2nd power. Anytime I take a negative and raise it to an even exponent, it's going to keep the term the same as it was from the beginning. So h of negative x is going to be 4x to the 4th, and the 3x squared is going to stay. So notice this function and the original function are exactly the same, which means it is an even function. And the reason why is because h of negative x is the same thing as h I did F again. H of X. And it says, what type of symmetry does this graph have? Since it's even, it's going to have line symmetry. Now, I don't even know what this graph looks like, but I do know it's going to look something like this, where it's going to come down and back up, and it's going to be line symmetrical there. All right, so we could kind of graph it in our graphing calculator if we want to. All right, you ready, Mia?
Hi, smart people. Okay, great. That definitely failed.
Hi, smart people.
Yeah, I failed.
You didn't fail.
Definitely did.
Oh, great. Let's see what happens.